This is the AQA AS Maths paper from May 2018, looking at paper 1, and we're on question 5. We're told that point C has coordinate little c 2, and point D has coordinate 6 and little d. We're told the line y plus 4x equals 11 is the perpendicular bisector of CD. I'm asked to find little c and little d, the coordinates of points C and D. Right, immediately it looks a little confusing. It's a 5-mark question, there's a lot to do here. But let's not get too worried, because we're told it's a perpendicular bisector. What are the things I'm likely to use here? Well, the minute it's perpendicular, that tells me straight away I'm going to use the fact that the gradient of one line multiplied by the gradient of a line perpendicular to it is -1. And I'm probably going to use that formula in a short while. It's a bisector, which means it splits it exactly in the middle. So if I know, even if it's just algebraically, the central point of C and D, I can use that to go into here, y and x, with these two unknowns, in order to calculate an unknown, and that should be able to give me either C or D, or likely both. And importantly, this is going to give me one equation, this is going to give me the other equation. I've got two unknowns in two equations, therefore it should be solvable. Let's have a go then. I'm told this y plus 4x equals 11 is the perpendicular bisector. I think it's worth sketching, however vaguely, where these points might be. C is going to be little c and 2, so let's say, for example, that's here. It could easily be negative, but it really doesn't matter. There's C and there's 2, just there, so that's going to be point C. And point D is going to be at 6. I don't know if 6 is bigger or littler than C. I don't really care, though. Let's suggest that's going to be 6 over there. And D, let's take D as being up here. And the reason I'm making it positive, it just means that if it comes out as negative, it's not very confusing for me. Let's call that D. So that's the line CD. Now y plus 4x is 11. I honestly don't know exactly how that line looks, but I'm pretty certain I've drawn this wrong, but it doesn't really matter. Let's say that's going to be my midpoint there. Let's call that midpoint M for ease of reference. So where's that midpoint M? What coordinate does M have? Well, the x coordinate is halfway between C and 6. So M is at, well, what's halfway between C and 6? Well, it's C plus 6 over 2. And the y coordinate, or the vertical component, is going to be halfway between 2 and D. 2 plus D, similarly, over 2. And that's my midpoint, M. And I know that that midpoint fits this equation, because that midpoint is on the line, which I'm going to draw here, which is going to be y plus 4x equals 11. So because that point is on that line, it must fulfill that equation. So I've got a midpoint, I've got an expression for the x and y coordinates of my midpoint M. Now let's see what happens if I can work out, use this bit where I'm talking about the gradients being 90 degrees to each other. So the gradients multiplying to -1 because these lines are at 90 degrees to each other. I ought to know the gradient then of the line CD. Well, the line CD goes between C and D. So what's the gradient here? Well, what's the change in vertical component? It's between 2. Sorry, let's do D first, shall we? It's going between D and 2. So it was, so I've gone from there to there. So I've gone down. Let me get this right. In going from C to D, I've gone across that distance there, which is 6 minus C. And from there to there, I've gone this distance here. And that distance there is D minus 2. And the reason it has to be that way around is I'm taking the right-hand coordinate, the D coordinate, and seeing how I got there from C. So my gradient then is the vertical change divided by the horizontal change. So that's going to be, the vertical change is d minus 2. The horizontal change is 6 minus c. That's the line CD, so that's the gradient of the line CD. I know the line perpendicular to it also has a gradient. And I know those gradients multiply to -1. So what's the gradient of y plus 4x equals 11? It shouldn't be that hard to work out, so I simply rearrange that to say that y equals 11 minus 4x. Then I can get the gradient from that straight away. It's going to be -4. The gradient then is -4, which tells me that the gradient of the line CD must be equal to whatever multiplies with that to give me -1, which must be 1/4. So here is going to give me a lovely equation for C and D together, which gives me, if I multiply both sides by 4, I get 4 lots of D minus 2. Multiply both sides by 6 minus C, 6 minus C. So I know now an equation for in terms of D and C, and I'm going to use that. Now I've got that, what can I do next? I know that my midpoint, M here, exists on this line over here. So let's put these coordinates into there, into the equation. So if I know that y plus 4x equals 11, let's put the point M on there. So every time I see a y, I can write 2 plus d over 2. So 2 plus d all over 2, plus 4 lots of c plus 6 all over 2 equals 11. That equation must hold. Let's clear that up a bit, shall we? 2 over 2 becomes 1, plus d over 2 stays as d over 2, plus, well, if I 4 and the 2, if they cancel to give me 2c plus 12, because that 4 over 2 acts as a coefficient of 2, that's going to give me 11. Let's multiply by 2, shall we, to get rid of that 2, and let's clean this up a bit. 11, I can take away the 12 and take away the 1, so that's going to give me -2 by taking away 12 and taking away 1. I get d over 2 plus 2c is -2. Multiply by 2 to get rid of the fraction, d plus 4c equals -4. So I've now got another equation in terms of d and c. And now I should be able to simply calculate that from this without, hopefully, too much trouble. So I've got an equation in D and C here, I have an equation in D and C here, I should now be able to solve it. Just so it's a little clearer, I hope, I'm going to create a little space over here to work in. So let's say that I know that from this equation here, D is going to give me -4 minus 4C, and over here I'm told that 4D minus 8 equals 6 minus C. Let's clean this one out a bit and say, or let's call that equation 1 and that equation 2. Let's clear up equation 2 a bit. And that tells me that 4D equals, well, add 8 to both sides, I get 14 minus C. Let's put that equation in. Let's put 1 into there. So every time I see a D, I can write minus or -4 minus 4C. So that's 4 lots of -4 minus 4c equals 14 minus c. -16 minus 16c equals 14 minus c. Add 16c to both sides and I get 15c over here. -16 added here, I get 15c. -16, I take away 14 and I get -30. So that tells me C is going to be -2. And having done that, I can put that value of -2 into, well, any equation really. Let's put it into here. So I then get 4D equals 14 minus -2. 14 minus -2 is 16. So D must be 4. So I now have my values for C as -2 and D as 4. That's pretty involved, and there may be a faster way of doing it, but that's certainly the way I would do it. forming two equations in two unknowns, using the fact that the gradients multiply to give -1 because it's perpendicular, and using the fact that it's a bisector, so I know that the midpoint, which I can calculate algebraically, must sit on the equation of the line I'm given at the start. Y plus 4x is 11.